While I think in general we enjoy the forests of the world, we sometimes don't fully appreciate the benefits they provide. They consume 1/3 of greenhouse gas emissions, provide a habitat for 80% of land, animals and plants, and provide a natural defense to disasters such as floods and landslides. Forests are today endangered by climate change, by deforestation, by many natural and human-made causes. And this means that they won't be able to provide their benefits on which we so much depend.
In the UK, we have over 3.25 million hectares of woodland, all of which are potentially vulnerable to pests and diseases. If an area is found to be infected, treatment is typically destruction through felling or burning, not only the infected tree, but the surrounding area as well, to ensure complete eradication of the pest or disease. However, we're talking about around 13% of the UK land area, and thus our ability to actively monitor this vast area is limited. And the earlier we can detect diseases, the greater our chances of minimizing this forest destruction.
During testing, it's common for a lab test on a physical sample to be carried out, which can involve a member of the forest management team climbing a tree and cutting a branch off. It's intrinsically dangerous.
We've seen a substantial rise in the capabilities of AI and autonomous systems, which is just brilliant for supplementing our limited human resources in many application domains. Forest health maintenance is no exception. UAVs in particular are incredibly flexible with their movement and can acquire rich information through a wide range of sensors.
There's an abundance of literature surrounding remote sensing, from satellite imagery to drone gathering data, as well as literature regarding how machine learning can be used to identify patterns in the collected data to help spot diseases.
There are also opportunities for utilizing ground robots, which have significantly longer battery life and can acquire 3D point clouds inside the forest. A series of such data sets collected over time can then be used to identify areas of the forest that might raise concern.
The canopy, though, blocks GPS signals, and with the forest containing few unique features, ground robots can easily lose orientation. However, we should not discount them, and there is research on UAVs teaming with ground robots, each lending their strength to the other, from positioning to battery life.
We also need to consider socio-ethical and legal concerns. The last thing we want to do is make the forests unsafe or discourage people from using them. The forests are a great support to our mental health and well-being. But think not only about physical harms, but also non-physical harms, such as noise disturbances and intrusions on our privacy.
In our in-house testbed, we can produce end-to-end systems. If there's an area that we want to survey, we can send a drone to initially scan the area and locate any unhealthy trees. These can be identified using machine learning. Once an unhealthy tree is potentially identified, we send out a robot to retrieve a sample. When the robot is close, we switch to manual control for the human operator to control the last part of the sample retrieval process. Then the sample is returned and collected for lab analysis.
Hyperspectral cameras, for example, capture hundreds of bands of light that the human eye cannot see. If we can understand which of these bands are most informative, this can greatly assist with the early detection of a diseased plant. Beyond sensors, there are even sampling tools, such as the DELEESE tool from Outreach Robotics, to safely gather samples for lab testing.
The ASPEN project is a fantastic opportunity to exploit the results of our fundamental research. We've been able to make a start on establishing a foundation to understanding how we can exploit the capabilities of autonomous systems in forest health, and we are committed on continuing our research into this worthwhile cause.